So, hello everybody. My name is Vladimir. I'm coming in front of the Bloxico company. We are a Web3 company, so we have different side of projects. One of the technologies that we are using is Solidity. So, as I know, this is like first of the series about the Solidity like language. So we will get some small intro and about the testing and optimization. So Solidity is a language that primarily targets the Ethereum network, Ethereum virtual machine, so EVM. It's object-oriented, high-level language. It's statical type. It supports inheritance like normal object-oriented language, and it supports complex user-defined types. So when you go deeper in defining everything and logic in Solidity, you will see that. There is basically three languages that influenced Solidity at the beginning. First language in the beginning was JavaScript, but most of the things that JavaScript influenced the Solidity was depreciated after the 0.4 version, and still you can see like function naming, that keyword function, also imports and scope of the variables, scopes inside the functions and outside. Most influence for the Solidity was under the C++, and we can see like a lot of different examples through the code, like type conversions, implicit and explicit loops, declarations, and everything. And last, that's, let's say, a newer version is Python, and like most things that we can see that Python influence Solidity is modifiers. It's in the Solidity modifiers is, let's say, performing like decorators in Python, something like that. They wanted to achieve that. And for example, super keyword that is inheriting everything when you're using it. So Solidity is basically a language that is implementing smart contracts to govern the state of the Ethereum network. Second thing that is important for like network as network, that you can look at the Solidity smart contracts as small Java classes or some executables on the network. But it can store the state, persist the state of whatever we defined. Also, it can perform computation, views, searches, and most important, it's immutable. So when you deploy smart contract on a network, it's not changeable. There is some ways for the replacing, like OpenZeppelin and other frameworks introduce like upgradable, but that doesn't mean that you're changing current contract. You're just replacing with newer contract that you're using in your application. There is a different approaches, and this part that is immutable, like smart contract, and that other point is that every operation have cost except, like we will see later, views from local node. But when you are storing some state, so whenever you're changing the state of the network, even if it's small, there is a gas fees that is involved and some cost. It depends on the network. It doesn't need to be Ethereum, but EVM-based network, there is a cheaper networks. It's based on a price of the native token on that network. So because of that, we need to take care of the testing and optimization in the first place, because in Web 2, when you're doing some development and deployment, you can deploy on production after you perform some testing searches and you see that something is not good, you can change it without the cost. In Solidity and EVM-based networks, so when you deploy it, it's immutable, so that part of the testing, it's, let's say, important. Regarding the testing, there is, like for development, there is different tools that use also for testing. First, let's say, oldest of the old tools is Truffle. Truffle is, we spoke before this, so Truffle is most mature tool. It's very well developed. Also, it has like Ganache, that is UI for the local network that you bring up, like you can use Ethereum Explorer, some Block Explorer. So you can look at the network from UI standpoint when you are testing and deploying on that your local network. And my opinion that it's very good for the people who are getting into it to learn and to get everything on place, because Truffle is structured, and when you start working in Truffle, it's not totally open that you type whatever you want. Truffle has he has structure, like architecture, where you're putting tests, how you're calling. Of course, everything is changeable via config files, but still they're like forcing you to do Truffle way, like how you're structuring your project. Truffle is using Mocha and Chai. It's based like JavaScript testing environments, and it's very well. Other tools are also using that tools. Next tool that is in that series is Hardhat. Hardhat is newer tool. It's not, for me, it's more powerful than Truffle because it have a big marketplace. It's also allow a lot of plugins, allow that you structure and set up whatever you want on a way you want to work. And Truffle is, Hardhat is also using Chai, like testing framework. It's everything automated in the background, but that is the framework they are using. What I see as an improvement for Hardhat, it's very well when you're writing tests in TypeScript. So if somebody is familiar with TypeScript, it will be easy for them to write tests on in Hardhat. Also, because we mentioned that gas fees are very important. That is something that Hardhat has, like gas profiler. You can like trace the gas for every contract function. So in that process of the testing and optimization, you can look how to lower down your gas fees, what is, let's say, most important. Third software is that most of the people are, whoever start doing something, it's online tool. You can download it and install it on locally, but most of the people are using like online. It's a Remix tool, and Remix tool has a different, let's say it's like a playground. Let me just see. Remix, it's like a playground. This is Remix, so you can put, type your contracts, you can compile it in different environments. You can use different, when you're deploying, you can deploy in virtual machine. You have different versions of the EVM, so you can play and test with the Remix a lot. So there is an option. They start building like testing environment that are pure testing. Here in Remix right now, you can just like you can just you can just like perform your own test on different environments, and that's something that is good. Last is Brownie. I wasn't working too much with it. I just wanted to mention, because people who is coming from Python world, Brownie is a good option because it's have a good console that gets profiling and Python integration. So you can use Python a lot. You have some tweaks and things that you need to do, but still that is good option to have. So two like main parts of the testing plus optimization. I see in first thing that like TDD development in Solidity means that if we are having some project, big requirements, smaller requirements, we need to have clear picture what contracts should do and should not do. I mean, what is not allowed. For example, if I have some ERC tokens, maybe it's allowed to go only to the owner of the smart contract, and I need to ban all the other functions to stop all other actors to invoking that transfer function, for example. So when we have like clear picture of the requirements and use cases, scenarios, I think, that's my opinion, that I like to work like that. First step, I take all the requirements, all the use cases, think about them, think about the workflows, and then I wrote the tests for every use case, but I'm writing the test to fail. That's my first step. I wrote every test that every test is failing. And then I start like, okay, this test is failing, for example, it expects 2 users that it get in return, for example, to some addresses, and I'm getting 3. So I create tests that it's always failing, then I'm looking through the smart contract, that specific function or workflow, multiple functions that I'm testing, and then I'm creating contracts on that side that it's not failing. So that's the first step. 2 main points is testing the workflows. So when we are doing TDD in Solidity, means that we want to cover all the use cases, and that's the first step. That doesn't mean that it will be optimized for the gas usage, that it will be maybe secured enough. It just means that when we wrote those tests in the first step, it means, okay, now we have covered all the use cases. And after that, we are looking for security. That's another main important of the EVM and other blockchains also, because when you deploy the smart contract, it's publicly viewed. So you can view every contract that is on the network current. You can view if you know the address, or you can search the contracts and you can see it. So everything is in some way open source. So in that case, we need to take care of the security, because if it's open source, if it's immutable, if we make some really security hole, it's hardly that we are going to change that easily. For that purpose, just note, there is, for example, some modifier that it's called posable in Solidity, where you can implement posable in some functions, like modifier, and say this function is, when you define it as posable. That means that when you, in some way, figure it out, that you need, you cannot destroy the contract, you can just like stop, of execution and everything, you can call that, owner of the contract can, for example, call that posable, and contract still exists, you can figure it out then how to fix the error, how to deploy another contract, do something else, but nobody can invoke that security bug anymore. So first step is covering all the use cases. Second step is, for me, it's security testing. That is most important. Also, and at the end, when it's secured enough, we have all the use cases, we are going to the optimization. So then we are looking, okay, now everything is secure, everything is working, but when I call this function in these conditions, it's using a lot of gas. For example, it will be costly. Nobody will want then to use it, like why to pay some, enormous amount of the tokens. At that moment, we are going to that part of the optimization, how to optimize the code. Regarding the testing, tests are written in, like I said, we are using Chai. It's TypeScript, JavaScript testing framework, and it's standard. All the other frameworks are using. It's not something that is too complicated. It is good to run through the documentation because they have a lot of useful functions that you can like compare, figure it out, different scenarios and everything. But regarding the security, there is like slow tools and fast tools. Slow tools, first of the slow tools, fast tools, sorry, is static analysis. What does it mean? It means that first step is that we know use cases, we know how to figure it out what can be like security issue, and then we look through the code, because in some cases security issue can execute normally. We are not going to get any error in any test or anything. So for example, a good example, if we are changing the state of the, on the contract, for example, we are having smart contract that is performing like vault and storing balances for every user who wants to deposit, for example. In that deposit function, we can put different things, steps, what is performing. For example, and two parts is like it's increasing the state of the balance for the specific user, and it accepts native tokens that user deposit. Imagine that order of execution would be increase the balance, accept the tokens. What if the user doesn't have like 50 tokens he wants to deposit, and he invoked the function, his balance in contract is increased for 50, and when it comes to the like transfer function, accepting the tokens, it will fail, but state will be there. So that is a like school example of the security issue. That when you write function like that, it's not going to produce any error. It's totally valid. But that first step is static analysis, that you look through the code, look again like use cases, what is allowed, what is not allowed, and then figure it out of the possible scenarios and fix that order. For example, okay, first do the transfer, and if transfer is okay, then increase the balance, for example. When I get the tokens, then I will increase the state of that token. Another thing is linters. I mean, linters is more like to be everything uniform. Hardhat has his own linters and everything. You can change that linting in configuration file, but it has good like linting that can fix automatically, like if you're using uppercase, small case, 2 empty spaces, some other things, you can do whatever you want. Tool that is free and it's good for starting point for like fixing at least base stuff, but it can do a lot more, is Sliter. Sliter is a tool mostly for the security checking and also for the linting, for that basic stuff, that when you run it on the code, it's open source, you're running like you're installing in like npm package or globally on desktop, whatever you like to use. When you run it, it produces a big log file and say, okay, in this contract, this line of code, for example, you're defining, I will show you example of the Sliter. So, no, so for the Sliter, let's say, for the Sliter, security testing. Okay, it produces, for example, warnings like this and say, okay, in this contract, this line of code, you're using address token ID. Is it immutable, not mutable? Are you naming for example, parameters that you want to return? If you're not, you can just put like uint parameter. I will return uint and that's all, but you can also name it. So Sliter is a very good tool that will point you and have different things like warnings, errors and everything. And if it's security error, it will be in red, like noticing, so this is like security error, you need to really fix this. Most of the use cases is that re-entrancy that most of the people are trying to avoid in smart contracts. OpenSAPL and in Solidity you also have modified, like you have a re-entrancy guard. So when you introduce to the function again, define like that, it will prevent some cases. It's not magic, but Sliter can do like different type of checkings, and you can put like different type of the scenarios that Sliter will check, and it's very good tool for that, at least fixing basic stuff. Maybe you miss something. It's not, so all of these errors, it's not going to be errors in compile, maybe warnings also, maybe not, but Sliter will cover a lot of things that you or other tools are missing. So that is the, let's say, fast tools. It's called fast tools because that is first step, and that is something that we are doing like fast. Okay, I done everything. Let's just run Sliter through all the contracts, and I will get some report, maybe to get some features or everything. Slow tools, it's much more powerful. I think it's paying metrics. I'm not sure. I'm not using all the time. So this is slow tools that you can define totally scenarios, different scenarios with fuzzy logic. You can do much more, but it needs to, like, you need much more work for them. Basically, it's audit companies are using most of the slow tools and they're like performing auditing of the smart contracts. It takes time, like 2 weeks, 3 weeks, depends on the project and size of the project, but that's some tools that are writing different, really complex scenarios, and when you come to that point, you need work only that. You're not like just Solidity developer. So that is regarding the tools and testing. So if we imagine a scenario that everything passed, like we have secure contracts, we have every use cases are covered, what we can allow, what we need to forbid, and we run like through the security checking and everything is working, and then you send the project to the like whoever want that project, and he said, yeah, but there is a limitations, we cannot run this, it's too expensive. Then you're going to part of the optimization. First part, when you start working, or probably a lot of you whoever worked see this like, okay, this size of the contract is big. Big point here is when you're writing smart contract locally, it's not looking size of the file that you're writing and you're having on your computer. So Solidity compiler is compiling that in a bytecode. That compiled bytecode is deployed on network. So when you get a message like this, like warning, this is warning, it's not, I mean, everything is working, but it's there is a possibility when you try to deploy this on mainnet, that mainnet network will refuse it and say, I don't want to deploy something big. So this is a part where you need to understand that it's not calculated the size of the file, you're not sending anything, you're compiling and deploying the bytecode. Why it's important? There is one function in Remix and all tools in config files, it's called optimizer. So you can say, okay, like it said, like consider enabling the optimizer with a low runs value. What does it mean? You can have the same contract and put the value of the runs, I will explain soon, for 10 runs. It will have much smaller size than you put like 100,000 runs. It's the same code, but it compiles in different bytecode. Why? That is your prediction how many times that smart contract will be invoked on a network when you deploy it through the history. And that is the part when you have some small helper contract, then you can just put like, okay, this is one time only, I will put like 100 runs, and you will compile smaller bytecode for the same contract. If it's same contract needs to be run over and over and over, you put larger amount. Then next thing that you can then get the sizing is using the libraries, like splitting the code in libraries. Then you can look the definition, how you define your vars inside the contract. So if the var is immutable, then it's, if it's not using the state or changing the state, if it's some fixed value immutable, you can save a lot of gas there. Then defining the time, what is like in some cases problematic on every blockchain to get current time. You're getting the time of the block that is in past. So how fast is the network? You need to think about that. Defining, there is a type in Solidity called address, like you have int string, you have address slice type. You can use address as type, but you can use put that address in byte 32, just different format, and you will also, you can save that gas. And then like redefine the loops, length of the loops, how much you're returning. That's the important and libraries I mentioned. Also using the pure and view modifiers. So when you're changing the state on the network, you're paying the gas. When you're reading something, but not reading for the whole network, like taking the values from the network, then doing some calculations, or you're not from the view calling some functions that are doing that. In that case, you're reading local node, and you can use pure and view, and that means that gas will go down. You're not paying the gas, you're just like telling the compiler, okay, when I call this function, I will just look at the node, this specific point in memory, and give me that value. So you're not doing anything. Also, I will send like useful links and everything, so you can run into. This is more like into all this. Question?